waves, DC electricity, and light. So these are the topics which will cover this unit 2. First, we'll discuss DC electricity. So starting the concept of current, electricity started with the basic concept of current. How we define a current or electric current? It is a flow of the charges or rate of flow of the charges that is simply known as electrical current. And the SI unit of current is ampere. We can, for a small current, we can use milliampere or microampere. So example, if you have a metal, a conductor, and inside this metal, the charges are moving. Actually, electrons move, but electron does not move in a straight line. Electrons are also moving randomly. There is a net resultant direction, but it is a continuous collision between the particles, the lattice. So it's not moving in a straight line. It is continuously changing the direction. So the movement of the charges, how many charges will flow through this conductor in 1 second, we call that as electric current. The SI unit of the current is ampere. It is denoted by A. The conventional current, the direction of the conventional current is from positive to negative, where electron flow is opposite. So if we have a cell, a positive, this is a positive terminal of the cell on the left hand side, and on the right hand side you can see a negative terminal of the cell. So the conventional current, if we say what is the direction of the conventional current, it is from positive to negative. But direction of electron flow is opposite. Electron travel in opposite direction, so they move from negative to positive. In reality, the movement is because of electron, but because these electricity laws are based on the assumption that the current is a flow from positive to negative, that is why we always take a direction of current as conventional current. So if you have a battery and you want to show the electron flow, so the negative terminal electron will move. But if you want to show the conventional current or direction of the current, so it is from positive to negative. So if there are greater number of the charges passing through a wire in 1 second, it means the current will be higher, and current is denoted by I, which is also the rate of the charge flow. So if we need current, current is charge. Q stands for the charge, and T is the time interval. So current is equals to charge divided by time. If we want to measure the current, the apparatus which we use to measure the current, that is known as ammeter. These are different ammeters, and the circuit symbol which we use for ammeter is circle with letter A. So example, in 10 seconds, 60 coulomb of a charge flow through a circuit. You have to calculate the current. So what will be the current if 60 coulomb of the charge is moving or flowing in 10 seconds? So current is charge divided by time. What's the answer for this? So 60 divided by 10, which is equals to 6 amperes. Another question, a current of 150 milliampere flow around the circuit in 3 minutes. Time should always be in second. How much electric charge flow around the circuit in this time? So what will be the charge? You need Q. Charge is the product of current and time. Keep in mind the unit conversion is important. This is milliampere. So that will be equal to 150 into 10 to the power minus 3 ampere. And time is in minutes, so it will be 180 seconds. So when you multiply these two values, you will get 27 coulombs is the total charge which will flow. Now, the material which is allowing the electricity, because some of the material allow the electricity to pass, some of the material does not allow the electricity to pass. So material which allow greater amount of electricity to pass through them, we call them as conductor. A material which does not allow electricity to pass through them, we call that as insulator. And the material which allow current but very small amount of current to pass through, like milliampere or microampere, we call them as semiconductors. So a material in terms of electrical conductivity can allow electricity to pass, so we call conductor. May not allow electricity to pass, we call insulator. And allow a small amount of electricity to pass, we call that as semiconductor. So why some materials are conductor, some materials are semiconductor, and some of them are insulator? Because the reason is that they have different internal arrangement of the particles. So when you take equal size of a semiconductor, conductor, and insulator. So what is the structure of the conductor or the metal? They have a lattice of a positive ion, and there are delocalized electrons. Electrons are moving within these structures. So they have more charges. But what is the structure of a semiconductor? Semiconductor does not have too many free charges. There are, but not too many. Means out of 1 million, one or two atoms, you will find they lose their electron and convert into ion. So there are, but not too many ions are there, like positive and negative, but very few of them. But for insulators does not have free electrons, free particles, free ions, so that they are not able to transfer the electrical energy because there are no ions. So the main structure is they have free charges, or we also use the term denoted by N. What is the meaning of N? N means charge density. The meaning of a charge density, it means number of free charges in unit volume. So how many free charges are there in a unit volume? Like example, I take a volume, same volume for conductor, semiconductor, and insulator. So which one will have the highest value of charge carrier, charge density? Conductors, semiconductors, or insulator? Which material will have the highest value of? So conductors will have the highest value because there are more free charges. So the charge density for the conductor is very high, charge density is low, and charge density is zero, like does not have any free charges in a unit volume. But this charge density changes with temperature. For conductors, already all of the atoms already lost their electron and changed to ion. So for conductors, charge density remain constant or does not change with temperature. But what happened for semiconductors, when you supply heat energy, you provide energy to the particle, so when you provide energy to the particle, so they start to lose their electron, or it create more charges. So what happened to semiconductors? The charge density increase with temperature. And for insulators, very high temperature can affect their charge density, otherwise it will also remain constant. So for a small change in temperature, it does not change or it remain constant. So this is the effect of the charge density. This is the effect of temperature on the charge density. For metal, it is constant. For insulator, more or less, very high temperature can affect. Otherwise, small change in temperature does not affect the charge density of insulator. For semiconductor, it is affected by increase in temperature, greater temperature. More atoms tend to lose their electrons, so the charge density increases. Then another thing is known as the drift velocity. What is the drift velocity? It is a displacement in unit time for the charge carrier. That's called a drift velocity. As I mentioned, the charges are continuously changing the direction and moving. Net resultant direction is there. So the displacement, what is the displacement? Starting point to the end point, that is displacement. So displacement divided by time, that's speed or velocity, is known as the drift velocity. Now, if I increase the temperature, what is the effect of increasing temperature on the drift velocity? Will it increase or decrease? So the effect of the temperature on the drift velocity, when you increase the temperature, the drift velocity will decrease. How the drift velocity decrease? When you increase the temperature, so the random motion increases. So they will have greater random motion, but the displacement will decrease. Like the charges will move faster, but they are having a greater random motion, so the net displacement will decrease. So when temperature increase, the kinetic energy of the charge carriers will increase, which result in greater random motion, leads to decrease in drift velocity, because drift velocity is displacement, the net displacement over time. So the net displacement with respect to time decrease, so that's why the drift velocity is decreasing. So temperature and drift velocity are inversely increase. Higher temperature, smaller drift velocity. Now we can derive a formula here. We can derive a formula for a transport equation. What is a transport equation? This equation relate current, the charge density, and the drift velocity of material, and we call this equation as a transport equation. And what is a transport equation? There is a small derivation. I will derive that. So you should understand how it is derived, and at the last how we can use this equation to show a relation between drift velocity, uh, charge carrier, and the current. So example, you have a material. Example, you have a material which is having area A. So you have a material with area A, and the length of this material is L from one end to another. Just a minute. Example, we have a wire which is having a cross-sectional area A and length L. And the number of the charge carriers present is denoted by N. And the drift velocity at which these charge carriers are moving, that is V. So if we need, because we are finding a relation between the current, drift velocity, and the number of the charge carrier. So we have the formula for current. Current is equals to charge divided by time. So what is the total charge? How you'll find the total charge? Basically, this is the charge density, charge present in a unit volume. So if I know the charge present in a unit volume, multiply by the total volume, I will get the total charges, because the current is refers to the total charge which flow in a unit time. So how I'll get the total charge? So total charge will be, so I can say current is equals to charge density. Charge density means number of charges present in a unit volume, multiply by total volume, and that is divided by time. So this will give us the total charge. Now current is denoted by I, charge density is denoted by N, the total volume, what is the volume? A is the area and L is the length. So total volume will be area multiplied by length. So area multiplied by length divided by time t. Now what about the total? This is the total number of the charge, but we know the charges here are electron. And what is the charge of one electron? The charge of one electron is 1.6 into 10 to the power minus 19 coulomb. That is the charge which one electron carry. So we will multiply this whole by Q. So we'll get the total number of the total charge. Because N into A into L, charge density into volume, is giving number of the charges. But the total charge will multiplied by Q. Then length divided by time. Distance divided by time. So what we will get? We'll get I, the current, is equals to N A Length divided by time or distance divided by time is velocity, so V Q. So this is called a transport equation where I is the current, N is the charge density, A is the area, V is the drift velocity, and Q is the charge of one electron, which is 1.6 exponent minus 19 coulomb. Is it clear, this derivation of transport equation? Any doubt? Is there any question or doubt related to this derivation? So how we can explain the effect of temperature on current? So how the temperature affects the current which is moving through the wire? Number one, the first one is for conductor. Using a transport equation, so effect of temperature on current using a transport equation. Number one, the first one is for conductor. So what happened? The transport equation state I is equals to N, A, V and Q. And if we increase the temperature, so if we increase the temperature, what happened? What is the relation of temperature with the number of the charge carrier? It is not affected. So here the things which are constant for conductors, you have this equation I is equals to N A V Q. So N is constant, that's why I circle. A is the area, that's constant. Q is the charge of an electron, that is also constant. So means that current depends on the drift speed. And what is the effect of temperature on the drift speed? Temperature and drift speed are inversely proportional. So if I increase the temperature, it increase random motion, reduce the drift speed. So if the drift speed decrease, what happened to the current which is moving through a conductor? That will also decrease. So the relation between temperature and current for a conductor, it is inversely proportional, that increase in temperature will reduce the current for conductors. But for semiconductors, I is equals to N A V Q. So what are the things which are constant? Area is a constant and Q is constant. But what are the things which are changing? The drift velocity is changing and the number of the charge carrier. The relation between temperature, if we increase the temperature, the relation between the number of the charge carrier is directly for semiconductor. And relation between the drift velocity and temperature is inverse for any type of material. So if we are increasing temperature, drift velocity is decreasing, number of the charge carrier are increasing, but overall what is the effect? The increase in number of the charge carrier is much higher as compared to the change in the decrease in the drift velocity. So overall the current will, so current is proportional to the product of A and N, A and V. Number of the charge carriers are increasing, but the drift velocity is decreasing, but increase in number of the charge carrier is much higher. That's why the product will also increase. So for a semiconductor, temperature and current are directly proportional to each other. When you increase the temperature, the semiconductor allow greater amount of current to flow through it. Is it clear, this part? Any doubt? So this transport equation is also important, which shows a relation between the current and charge density as well as the drift speed or drift velocity.